In section 7 of chapter 2, we're going to be graphing square root functions with individual transformations. And just like all the others, I'm going to assume you don't know what the square root function looks like. You don't know what a function looks like, you gotta use an XY table, an input-output graph. So, I'm going to pick numbers for X, I'm going to pick numbers for Y. If you're writing in pen, do not copy what I'm about to write because I'm about to make 2 mistakes. Let's see if you can catch them. I'm going to pick values to plug into X. I'm going to pick same ones I always pick. -3, -2, -1, 0, 1, 2, and 3. I'm going to take those inputs and plug them into my equation and find my coordinates. First, I'm going to plug in -3. The square root of -3 is imaginary. It doesn't exist, not in the real sense. We're going to explore this more in the coming year. But that doesn't exist on an XY grid. So that means this function doesn't exist at x equals -3. In fact, does not exist. It doesn't exist for any negative number because there's a golden rule of mathematics, which again we will break this year, that you cannot square root a negative. That's only somewhat true. The first number I picked that I can actually plug in is 0 because the square root of 0 is asking what number times itself is equal to 0? It's 0. So I got my first coordinate, 0, 0. Then I'm going to plug in 1. The square root of 1 is really asking what number times itself, that's what a square root says, what number times itself is 1? The answer is 1. 1 times 1 is 1. And here's where we get to the second issue. Square root of 2. It exists. It's a number. It's not a number any of you can pick up off the top of your head unless you have some crazy memorization ability and you decide to memorize all the square roots. Square root of 2 does not square root very nicely. Neither does the square root of 3. Those numbers suck. Let's be smarter. Let's think ahead and pick numbers that are going to be nicer to square root. First one being 4. Because if I take the square root of 4, the number times itself that's equal to 4 is 2. So we're going to go right 4. Oh, I forgot the 1, 1. There's 1, 1. I'm going to go right 4 up 2. Then the next number that I can square root is 9. The number after that would be 16, then 25, then 36, then 49, then 64, then 81, then 100, 121, yada, yada, yada. It's just the perfect squares. Square root of 9 is equal to 3. So we're going to go right 9 and up 3. And this is the graph of the square root function. Now, if you look at it, you might begin to start noticing some things that are peculiar about it. First, I'm going to use some vocabulary from the past. Domain and range. This is our first paired function that has some major limitations to the domain and range. The domain, which you're not going to need to really utilize, I just want to showcase. The domain is where a graph exists in the x direction. It's how far it exists to the left and how far it exists to the right. This graph, this is as far to the left as this graph exists. But it keeps going to the right forever. So the domain would be 0 to infinity. The range, this is the lowest it gets. And it keeps going up forever and ever. So the range would be from 0 to infinity. We'll discuss this further as the year progresses, but I want you to start thinking about domain and range when looking at graphs, because that is inevitably where we're going. Second, this graph should look very familiar to you. If you lean your head a little bit to the right, this is 1/2 of a parabola, which is why a square root function is related to a square function. Same names, there must be a connection. We will investigate that going forward. Quadratics are a big, big theme in Algebra 2. This is one of the themes which we will investigate further in the year. But for right now, I want you to be familiar with the fact that they have a connection. besides just the algebra. All right. Rest of the class, you are going to be graphing these with individual transformations and describing the transformations. Later on, we will do the next lesson, which is dealing with all the transformations in singular problems.